Have you ever wondered how stars work? And we're not talking about these stars. We are talking about the ones we see in the sky every night. First, we have to know what a star is. Stars are huge balls of gas which are held together by gravity. And now that we know that, we are going to explain how they work. The life of stars begins in the nebulae, giant clouds which can be more than 600 light years wide, like the nebula of the Tarantula, and that are constituted by gases and chemical elements that are in the form of cosmic dust.
This cloud begins to shrink and contract due to its own gravity, and in the process it fragments into smaller groups. These fragments continue to contract, and as a consequence, pressure, density and heat increase in their center. This happens because the atoms move faster and faster and collide with each other. Under these conditions, nuclear fusion reactions begin, and when the temperature reaches 10 million degrees, the fragment becomes a new star.
Well, stars are extremely hot. But where do stars get this energy from? And the answer is nuclear fusion, and we'll see what this is.
Here we have a star. Gravity is all the time trying to contract it, but inside it, a lot of energy is being released to counter-react the gravitational force.
Okay, but I don't understand. Why is the gravity trying to contract the star, trying to squeeze it?
And this is an interesting topic. This happens because stars are really massive. Here we have a person. Let's name him Steve. Steve is attracted by the gravity of our planet. And here we have a star. And the same thing happens with them. The unbelievably strong gravity force that is created in them tries to pull its surface to its center. But this force is neutralized by the energy that's released inside. And that is why stars are all the time at the edge of gravitational collapse. Well, but let's go back to talk about nuclear fusion and how it avoids the death of stars. Lighter elements, that are the ones we can find at the beginning of the periodic table, are fused to create heavier ones, releasing energy that allows the star not to collapse under its own gravity, because this energy counter-reacts the force of gravity.
In the case of the Sun, the hydrogen nuclei fuse to form helium, releasing energy that serves the star to fight against gravity. Then, the helium that was obtained fuses to form carbon, releasing energy. In our star, the fusion ends in this stage, but in the case of more massive stars, the carbon goes through a really long and complicated process, but finally merges to form magnesium, some sodium and neon. When the core of the star heats up and the temperature rises to 1 billion degrees centigrade, the neon fuses again to form more magnesium and some oxygen, which then creates silicon, releasing energy.
Finally, in really massive stars, the temperature rises to more than 2 billion degrees, and silicon fuses to form iron. And we will see why, but this is a huge problem. It doesn't matter if you have never heard about the elements we have just talked about. This is basically how stars avoid collapse. They do it by releasing energy through nuclear fusion reactions that require more and more temperature to continue.
Finally, the fusion mechanisms result in a large amount of iron. And as we have already said, this meant a big problem for the stars. But why?
The mechanism of nuclear fusion serves for the stars to release energy and remain stable. For example, when two nuclei of hydrogen are fused, they form a nucleus of helium, releasing energy as they do that.
But iron, when merged, does not release energy, but absorbs it. This is terrible for the stars since gravity begins to win the battle, because there is nothing that can stop it. Once the star runs out of fuel for nuclear fusion, it begins to collapse, and there is a law that tells us what will happen with it. This law is called Chandrasekhar limit, and it is used to determine whether the star will turn into a white dwarf, into a neutron star, or into a black hole. For small stars, with a mass comparable to the mass of the Sun, its nucleus will be transformed into a white dwarf, an object as massive as the Sun, but of a size similar to the size of the Earth.
If the star is about 8 times more massive than the Sun, it will collapse even more, and it will have the size of about 10 kilometers in diameter. When collapsed, the protons and the electrons will merge, leaving only neutrons, which will be responsible for resisting the pressure of gravity, repelling each other.
If the mass of the star is 15 times bigger than the mass of the Sun, it will completely collapse and there will be nothing that can counteract gravity. Then, the star will be transformed into a black hole. The entire mass of the star will concentrate on an infinitely small point. And this is why, at a certain distance from the black holes, nothing can escape.
As a final reflection, I think more people should be involved in science, since it's incredible and also because it's the best tool we have to understand our world and our universe. Everything that we talked about in this video was discovered because there were people that wanted to solve the most exciting mysteries of our universe, just out of curiosity. And that is why I believe that curiosity and imagination are the things that keeps us going as a society, what makes us develop as humans. And as Stephen Hawking said, look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious.